Hello guys, welcome to Technical Campus, and in the last class we have learned about the process of matrix multiplication and the criteria of matrix multiplication, and today we'll quickly learn about some important properties of matrix multiplication. So suppose A is a matrix whose order is 3 cross 2 and B is a matrix whose order is 2 cross 4. So if we multiply these two matrices, suppose AB, so the order of AB should be 3 cross 4, 3 cross 4. Okay, so the order of AB is 3 cross 4. How it is come? If we look the basic criteria of the matrix multiplication, so suppose A is a matrix of order m cross n and B is a matrix of order n cross p, then C is a product matrix of AB whose order must be m cross p, as because while multiplying two matrices, the second element or column of first matrix must be equal to the row of second matrix. Okay, so when these two are same, so the order of product matrix must be m cross p. Now suppose if we multiply two matrices of order 3 cross 2 and B of order 2 cross 4 and we get a matrix AB 3 cross 4. We multiply a matrix of order 3 cross 2 and we multiply another matrix of order 2 cross 4, as this the column of matrix A is equal to the column of is equal to the row matrix B. So in this case the matrix multiplication is possible and the product matrix is of order 3 cross 4. Suppose we want to multiply the same matrix but in reverse order. Suppose we want to multiply B with A. So let's once write the order of B and A. So order of B is equal to 2 cross 4 and order of A is equal to 3 cross 2. So you can see in this case this element is not equal to this. The column of B is not equal to the row of A. So in this case the matrix multiplication is not possible. So from this we can learn the first properties of matrix multiplication, that is, if AB exists, you can see here AB exists, the multiplication of AB is possible, then it is not necessary that BA also exists. Okay, you can see BA is not possible. Okay, so this law is known as the commutative law of matrix multiplication. The commutative law of matrix multiplication So the matrix multiplication is not commutative. Why not commutative? Because AB does not imply the existence of BA. So we cannot say the matrix multiplication is commutative in nature. So guys, you can get short question from this type of properties, that if AB exists, if the multiplication of matrix possible, two matrices are possible in the order of AB, it is not necessary that BA also exist. But if these two matrices are square matrix of same order, okay, suppose A, B are the matrix whose order are same and both these are square matrix. Suppose A is of order 3 cross 3 and B is of order of also 3 cross 3. So in this case AB is also possible and BA is also possible. So this is only in the case of square matrix of same order, but generally if AB exists, it does not mean that BA must exist. If the order of the two matrices are not same, then this law does not following. So we can say the first property of matrix multiplication is that matrix multiplication is not commutative. Okay, the second property, if you want to see, that is about the associative property of algebra. So first property is the matrix multiplication is not commutative. Okay, and the second property is the matrix multiplication is multiplication of matrices is associative in nature, associative in nature, okay, in nature. So what is associative? What is associative property? That is A into BC is same as AB into C. This law is known as associative law of algebra. So the first property you have learned that matrix multiplication is not commutative. Why not commutative? Because of row column rule of matrix multiplication. As because there is a rule known as row column rule which must be followed before multiplying any matrices. That's why the matrix multiplication is not commutative. But the matrix multiplication is associative in nature only when there is a special condition. What is the condition? Only when conformability exists. Okay, what is conformability? Let's now learn about conformability. So suppose A is the order of A is m cross n, and order of B is n cross p, and order of C is p cross q. Here you can see as we are dealing with the three matrices, so the order of three matrices are respectively m cross n, m cross p, and p cross q. You can see that the multiplication of AB is possible because this element, first element of B and second element of A are equal. Multiplication of B and C is also possible because the first element of P is equal to, the second element of P is equal to the first element of C. So in this case, if AB multiplication is possible and BC multiplication is also possible, you can see that the column of A is equal to the row of B, and similarly the column of B is equal to the row of C. So in this case, the multiplication of AB and BC is possible. So we will say in both these three matrices, in all these three matrices, conformability exists. So the matrix multiplication is associative in nature, and only when the conformability among all the three matrices are exist. So what is conformability? Conformability means the multiplication of AB and BC are possible, okay? Because only when the row column criteria will be fulfilled, then only the multiplication of matrix is possible. So if conformability exists, then the matrix multiplication is associative in nature. So we have learned two important properties. First property is the matrix multiplication is not commutative, and second property is matrix multiplication is associative only when the conformability exists between all these three matrices. So guys, so let's learn quickly about two more important things in matrix. First is trace of a matrix. What is trace of a matrix? This is very simple. If trace only deal with square matrix, okay? Square matrix, only for square matrix. Why square matrix? You can see that the meaning of trace means the sum of the elements lying along the principal diagonal of any square matrix, okay? So you all know that principal diagonal exists only in the case of square matrix. Suppose this is a matrix 1, 2, 5, 3, 7 and 8, minus 1, 0 and 3. So here you can see this is a square matrix, and if you want to learn the trace of a matrix, then the matrix must be a square matrix, and we will deal with the principal diagonal element. So here the principal diagonal element is 3, 7 and 1, okay? So trace of any matrix is the sum of the all elements lying along the principal diagonal, okay? So this is the matrix A. We will denote the trace of a matrix by this notation, TR of A. Trace of matrix A is equal to simply the sum of the all elements lying along the diagonal, lying along the principal diagonal, that is 1 plus 7 plus 3. So trace of this matrix is 7 plus 3, 10, 1, 11, okay? So now let's learn about the transpose of matrix. I think you all know about all these things, and I also go through the quick revision process, as because very simple question may ask, and if you do not know the basis of all these things, you cannot do the basic question which may come in GATE. Okay, so let's learn about the transpose of matrix. Okay, transpose of matrix. So suppose A is a matrix. Suppose let's take a defined above matrix 2 1 2 3 4 and 5 6. Okay, so here the order of A is, the number of row is 3 and number of column is 2. So the order of this matrix is 3 cross 2. Okay, because the number of row is here 1 2 and 3 and number of column is 1 and 2. So the order of A is 3 cross 2. And if we reverse this arrangement, reverse in the sense, if we write the reverse of the order of this matrix, that is, if we want to write the 2 cross 3 order of the same matrix, then the order of the matrix will be 1 2 3 4 5 6. We have just reversed the row in the place of column and column in the place of row. Okay, so if there is a matrix of order n cross m, and if we reverse the matrix by changing its row into column and its column into row, then it's called transpose of matrix. So here A is equal to, here this, you can see this is the main matrix and this is the transpose of A, that is AT. Okay, so it is very simple. So you can denote the transpose by AT or A dash. Okay, so what is transpose? Suppose a matrix of order m cross n, and then the n cross m. Suppose a matrix of order m cross n, then the matrix of order n cross m, okay, obtained from the same matrix by changing its row into column and column into row. That matrix is known as the transpose of that matrix. Let's take another example. Okay, suppose a matrix B is equal to 1 2 3, and this matrix have only one row, you can see, and 3 column 1 2 3. So this is 1 cross 3. So the B dash or B transpose equal to, simply we have to make 3 row, that is, and we have to reverse this 1 2 and 3. So the order will be 3 cross 1. So you can see the whole order and reversed. So this is known as transpose of matrix.